What's going on, Algebra class? Got a standard deck of cards here. Since we've been talking about probability, obviously some of your probability problems deal with cards. I got the dice here as well. Some of the common math probability items and events. Little penny, coin, heads and tails. The classic bag O objects. Got a bunch of golf balls in here. There are actually 20 golf balls in here. And one little misfit. There it is. The pink golf ball among the 20 golf balls. So we talked about simple probability before. Basically, if you're just dealing with one die, what's the probability of getting a number, or maybe an even number, an odd number? So you just look at how often that desired event can occur. Let's say if it was an even number, there are 3 even numbers out of 6 total things that could happen. What's the probability of getting the Queen of Hearts? Well, there's 1 Queen of Hearts out of 52 total cards in a deck. So things like that. What we're going to look at today, though, is what if we have more than one event going on? What if we're not choosing just one card or rolling one die? All right, so what we have to look at is something called an independent event. Independent means that it doesn't depend on anything, it can rely on itself, and really in probability what it means is it's not affected by anything else. So let's say that I was going to take this die and this coin, and I want to talk about, the probability of what if I get an even number and heads? What's the probability of that happening? All right, now, when I roll this die, this obviously has no effect at all on how I'm going to flip this coin. All right, so that's why we can consider them independent events. All right, in the same way, I can flip the coin, and it's not going to have any effect on me rolling that die. So that's why they're considered independent. All right, so when you need to find the probability of an independent event, it's very simple. All you need to do is actually multiply the probabilities of what you're looking for. So if we wanted an even number on the die, that has a probability of 1/2 because half of them are even. If we wanted a head on here, that has a probability of 1/2. So the probability of getting an even number and a head, we would have to take 1/2 times 1/2, and we would get 1/4. All right, so that's how these probabilities work. And same goes true if you're rolling more than one die. All right, so I've got two different dice here. All right, if I roll the white one, it has absolutely no effect on how I'm going to roll the black one or what will come up on the black one. So even though they are both dice, they are independent of each other because they have no effect upon one another. And all of these would be independent. All right, so say I wanted to roll a die, maybe I wanted to get a 3, and I wanted to get the pink ball. So what would the probability of that be? Well, to get a 3 is 1 out of 6. To get the pink ball, take my word for it, there are 20 golf balls in here. It's 1 out of 20. So we'd have to take 1/6 times 1/20th, and we would get 1 out of 120. All right, so to find the probability of independent events, when there's more than one event going on, you just have to multiply the probabilities together. So let's go ahead and take a look at some of the problems you're going to have for your assignment this week on Alex. So this particular problem is talking about a coin being tossed twice. So when you think about a coin being tossed twice, if you get heads on the first toss, it really has no effect on what you get on the second toss. You can still get heads or tails. And the next toss, you can still get heads or tails regardless of what you got on the first roll, the second roll, third roll, and so on. So that's why they are considered independent events. So in this situation, it's asking for the sample space of what could happen if we toss this coin twice. And they say use H and T for heads or tails. So what we could do is we could get heads on the first flip and heads on the second flip. So that would be heads, heads. We could get heads on the first flip, but tails on the second flip. So it would be heads, tails. And then we could get tails on the first toss and tails again. Or we could get tails and heads. All right, and those are all of the possible things in the sample space. An easy way to figure out how many items you have to have in the sample space think of the total number of outcomes for each event. So if I toss a coin one time, I have 2 outcomes, heads or tails. I toss it another time, I have 2 outcomes. So I take the 2 times the 2 and I get 4. All right, so that's how you determine how many items are going to be in that sample space. Just kind of double check to make sure that you have the right amount. All right, so now the next part is, what is the event that the second toss is tails? All right, so you can look at your sample space to figure out how many times that event can happen. So this one right here has a second toss of tails, and this one right here has a second toss of tails, but not the other ones. So that event can happen 2 times. So we're going to put HT and TT for the event that the second toss is tails. So 2 ways that could happen. Got another question similar to that. All right, so a box has 3 cards numbered 1, 2, and 3, and a bag has 3 balls labeled A, B, and C. So the first thing I want to talk about is the total outcomes. So just like I talked about before, I'm going to take the total outcomes from each event. So there are 3 outcomes for picking a card, and then there are 3 outcomes for picking a ball. So there are going to be 9 total things in this sample space when he randomly picks a card from the box and then gets a ball from the bag. So they're saying, let's use the numbers obviously for the cards and the letters for the balls, and try to be systematic with this. All right, so what I mean by systematic is kind of follow a rule. So let's do all ones first. So I could get 1A, I could get 1B, and I could get 1C. All right, after all the ones, I can get 2s. And same thing, I can get a 2 and an A, I can get 2B, and I can get 2C. And then we go through all the 3s. I could get 3A, I could get 3B, and I can get 3C. And that gives me all 9 outcomes like we talked about. Now they want to talk about, what is the event that the letter C is chosen? Well, if we look through our sample space, there are 3 ways that occurs. A 1C, a 2C, and a 3C. And later on, you can see where this is going when we look at the probabilities. All right, if they want to know if there is a letter C chosen, there are 3 ways that the letter C could be chosen out of 9 total ways, so that would simplify from 3/9 to 1/3. And just in case you were wondering, they do accept lowercase letters. It doesn't have to, it's not case sensitive for this. That's not a big deal. All right, so now we're looking at a coin is tossed 3 times, and outcome is represented by all of the H's and the T's again, so nothing unfamiliar here. The 8 outcomes are listed, and if you think about it, 3 times, you have 2 times 2 times 2, which gives you 8. And they want to know, what about the probabilities for each of these events? All right, and they're kind of walking us through this step by step. So 2 or more tails occur. So this one has 2, this has 2, this has 2, and this one has 2. So altogether, when we count that, there are 4 of them out of the 8, and that's going to simplify to a probability of 1/2. All right. Event B, no tails on the first 2 tosses. So if you think about that, the first 2 tosses have to be HH. So that occurs there, it occurs here, and that is it. There are only 2 of those out of the 8. So 2 out of 8 simplifies to 1/4. And then event C, a head on each of the first 2 tosses. So we need HH, and that is actually the same as no tails on the first 2 tosses. All right, so if there are no tails on the first 2 tosses, that means you have 2 heads on each of the first 2 tosses, and that is also 1/4. I always fear when I'm doing these videos that I'm going to get a question wrong, but I guess that's why they can make edits on these videos in case that happens. Hasn't happened yet, though. All right, a coin is tossed 3 times, so same idea. Exactly 1 head, so I go through here. There's exactly 1 head. This one doesn't count because it has 2 heads. That one doesn't count because it has 2 heads, so I keep going through and trying to find 1 head. There's 1 head, and there's 1 head. So it occurs 3 times out of the 8. No simplifying involved in that one. 3/8. A tail on both the first and the last toss. So that one satisfies that event, that one, and that's it. So just 2 out of 8 or 1/4. And then 2 or more heads. So this counts because it has 2. This has 2. This has 2 heads. And this has 3. 3 qualifies as more than 2. So that is 1/2 of them because it is 4 out of 8. So 1 out of 2 for our probability. Continuing on. Now we're talking about a spinner. All right, and we're going to spin this twice. So once again, we're not looking at the second spin has no dependence at all on the first spin. It doesn't matter if you get a gray or a blue. On the first spin, you have the same chance of getting gray or blue on the second spin. If you need to, you can kind of draw a picture. So if I have a spinner, I've got 8 equal size sections, so kind of like a pizza, and we're just going to assume that they're all equal. And we have 2 gray, so I got a gray, and then I got 6 that are blue. 1, 2, 3, 4, 5, 6. So if you need a visual, there's kind of your visual. All right, so a spinner is spun twice. What's the probability that the first spin lands on gray? So we look at the first spin. We want that to be gray. Well, there are 2 grays out of 8 sections. And then the second spin, we want to be blue. And there are 6 out of the 8 blue. All right, now, we could just multiply these, or we could actually simplify them first before we multiply them. I like that idea better because it leaves us with smaller numbers. So 2/8 is going to simplify to 1/4. 6/8 is going to simplify to 3/4. And be careful not to add these two together. All right, that's not how we look at the probability of compound events. All right, otherwise you would get 1, and 1 means it has to happen. And there's no way that this will absolutely happen all the time. So remember, it's multiplying. So to multiply these fractions, 1 times 3 is 3 in the numerator. 4 times 4 is 16 in the denominator. So we have a 3 out of 16 chance that the first spin will be gray and the second spin will be blue. So let me go ahead and put that in there. 3 out of 16. All right, moving on here. Science class has 5 girls and 3 boys in 7th grade, 4 girls and 4 boys in 8th grade. Teacher randomly selects a 7th grader and an 8th grader for the class competition. What's the probability that they are both boys? So once again, we're looking at the individual probabilities. They have nothing to do with each other because she is choosing from the 2 different grades. So the first one, the 7th grade, has to be a boy. And if we look at the 7th grade class, there are 3 out of 8 total students. All right. Make sure that you're not looking at 3 to 5. That's not the way it works. Those are called odds. And we're looking at probabilities, not odds. So we've got 3 out of 8 boys in 7th grade. And in 8th grade, we've got 4 out of 8 boys. And once again, I'm going to go ahead and simplify that to 1/2. So the probability of a boy being selected both times, I need to multiply 3/8 times 1/2, and that gives me 3 out of 16. So I'm going to go ahead and put that answer in, 3 out of 16. It's a very popular answer, it seems. Another correct answer. We're on fire here. Box contains 2 plain pencils and 2 pens. A second box contains 3 colored pencils and 7 crayons. One item from each box is chosen at random. What's the probability that a plain pencil from the first box and a colored pencil from the second box are selected? So once again, we look at these probabilities independently. So the probability that we get a plain pencil, we've got 2 plain pencils out of 4 items, which is 1/2. And a colored pencil from the second box, we have 3 colored pencils out of 10 total things. That can't be simplified. So to find the probability that both things are going to occur, multiply. 1 times 3 is 3. 2 times 10 is 20. So we have 3/20ths for the probability here. A couple more questions to look at. An ordinary fair die is a cube with numbers 1 through 6 on the side, so just like a normal die. Imagine that such a die is rolled twice in succession, all right, and the face values of the 2 rolls are added together. So their sum is recorded as the outcome of a single trial of a random experiment. All right, now we've got a slightly different notation to look at here. So we're looking at the probability that the sum is greater than 5. All right, and for this particular problem, I'm going to look up all of the outcomes, because if you think about it, if you're rolling a die twice, you've got 36 outcomes. So we've got 6 times 6 as our sample space, and those are actually pretty simple to find on the web. Let's see. 2 dice roll outcome chart. That ought to be what we're looking for. Okay. I like this one because it actually shows the dice here. All right. I want to make this a little bit bigger. So once again, we are looking at adding these numbers up and getting more than 5. All right, so I'm going to try to find all of the ones that are more than 5. We can eliminate a lot of these already. So I can eliminate almost this whole entire first column. All right, so I've got a sum of 2, of 3, of 4, and 5. Remember, it's greater than 5, so that one doesn't count. But the next one is 6 and 7, so those count. We've got these 3 are gone, these 2 are gone, and this one is gone. So now everything else is 5 or is greater than 5. So I've got 6 in this column, 6 in this column. I've got 5 there, 4 there, 3 there, and 2 there. So adding all of those up, 2 plus 3 is 5, plus another 5 is 10, 14, 20. We've got 26. So 26 total ways that we are going to get a sum higher than 5. So let's go ahead and go back to Alex real quick. Oh, I guess I got to hit done here. All right. So we've got 26 ways that a number is going, or that the sum is going to be greater than 5. And remember, that's out of 36. So write your answers as exact fractions. They don't want you to make this a decimal or anything. And this can be simplified, so we can make this 13 out of 18. So that's our first probability for event A. Event B, the sum is divisible by 6. So now we're going to go back to that chart and we're going to look at all of the sums that are divisible by 6. Before I move on, I just want to mention real quick, the P of A, that means when you see P in parentheses, that means probability of whatever is in parentheses. And in this case, they said A, and they clearly say what event A is. So this is really saying, this is the shorthand version of saying what is the probability that the sum is greater than 5. When we have P of B, and we know that event B is the sum is divisible by 6, P of B means what's the probability that the sum is going to be divisible by 6. So once again, I'm going to go ahead to this 2 dice chart, and I recommend you doing the same. go ahead and open up a new window so you can see the dice chart. And we're going to find out what is divisible by 6 here. All right, so 6 is divisible by 6. So I want to identify all of the 6s. So 5 and 1, 4 and 2, 3 and 3, 2 and 4, and 1 and 5. All right, and the nice part about these charts is you can recognize some patterns pretty easily. All right, so the next number that is divisible by 6 when you add these together is 12. And there's only one way to get 12. So when I'm looking at all of these, I've got 1, 2, 3, 4, 5. I got 6 ways that we can get something that is divisible by 6. And 6 out of 36 is going to give us 1/6. So we're going to go ahead and put in 1/6 as our answer. All right, the streak continues. So same idea. The sum is greater than 6 is event A. So we're going to go back to the dice chart. We're going to find out where they are greater than A. Actually, I'm sorry, greater than 6. I'm going to do this slightly differently here. I'm going to look at the complement. The complement is everything else that can happen because there's a lot of these that are greater than 6. So I'm going to find the ones that aren't greater than 6 and then just use some subtraction. So everything, like I said, there's some nice patterns with these charts. So I got kind of everything right here. All right, those are all the ones that are 6 or under. So I've got 5, 4, 3, 2, and 1. So I've got 9, 12, and 15 total. All right, so 15 total are 6 or less. So I'm just going to go ahead and think, all right, well, 36 minus 15 is 21. So 21 are going to be greater than 6. Now, as I mentioned, you could add all of these up too to get the 21. 1 plus 2, 3, 4, 5, and 6. That would give you a sum of 21. And we're going to go back and put in 21 out of 36. I am curious here. It does not say to put these in simplest form. So I'm going to risk putting 21 out of 36 here, even though it can be simplified. Both of these are divisible by 3, so you could have 7 12ths. But I'm just going to see if they're going to... I don't see where it says put in simplest form, so we're going to risk it here and put 21 out of 36. All right, next, the sum is an even number. So we go through and look at all of the sums that are even numbers, and you might be guessing already that there's going to be a clear pattern. Here's an even number. That's an even number. That's an even number. And it's basically going to be every other one, which you can kind of guess already that it's going to give us a 1/2 probability. You see 3 in every column are circled out of 6, so that's going to just be 1/2 here. So we'll go ahead and throw 1/2 in here. And we've got a correct answer. Now it does say, Alex kind of yells at us a little bit, says that the fraction can be simplified as we mentioned, but it did accept it. So any of those of you who were wondering about that, that's what we can have here. Well, let's go through one more problem. Why not? A spinner has 10 equally sized sections. 6 are gray, 4 are blue. We're going to spin this twice, so they're independent, so we just have to multiply the individual probabilities. What is the probability that the first spin lands on gray and the second lands on blue? So a gray spin, we've got 6 of them are gray out of 10. And the second as a blue spin, we've got 4 out of 10. So I'm going to simplify these to 3/5 and 2/5 to multiply them and get 6 25ths, which cannot be simplified anymore. So the answer is 6 out of 25 here. So as we've been doing for quite a while now, going through your assignments right here on Alex so you can get an idea of how to do each and every problem. So your assignment is entitled Probability of Compound Events. There are 10 questions on this assignment in Alex, 1 point each for a total of 10 points. A little different for this one. This one is not going to be due by the end of this week. It's actually going to be due Wednesday of next week. So you have almost an entire week to work on this. And then after that, there is only one assignment left to go in math for the entire year. So let's go ahead and finish strong here. We're going to look at some more events and things that can happen. And then that will be the end of the year. And we've been advised by the administration to leave the last week of school empty and allow people that are a little bit behind to catch up on some work. So if you are in that boat where you're a little bit behind and you need to catch up on some work, you will have that opportunity. Good luck, and as always, you can Zoom or email me if you need any assistance.